Okay, welcome back. Let's start with the T-joint. So I'm going to do File, New, Part. Make sure I'm in inch, pound, second. And on this, the origin does matter. The orientation, I think you can get away with any of the default planes, honestly. But on this first sketch, we do want to use the origin as a midpoint. And on one of the lines that we're going to revolve, one of the lines of the shank, and you'll see. So I'm going to start off of that. So I'm going to start with this sketch, and I'll just go ahead and use the front plane. And this one's relatively easy. I'm not too sure how the book does it, but this is how I like to do this one. And get back into a line, and I do half of the revolution. Then I select circle, and I'm going to put one here as well. And let's start with this, and this is the smaller line is coincident. This and this, the smaller line is coincident. And this top line is going to extend out just a little bit. So this line length is going to be slightly longer than this line length. I'm going to smart dimension off the drawing with the linear dimension. Actually, I'll start with the linear dimension as 3.268, and then I can do this other linear dimension is half of the diameter of the revolved T-joint. So I'm going to go 0.55 divided by 2, that's the radius. And then I'll go ahead and I'll add the diameter. It's going to be the inside diameter, so it's 0.375 times 2. That looks pretty good. I'm going to make this arc and hold control, and these two arcs equal in size. And this is looking pretty good. This is exactly what I want. Pull this over like this. And I think that's it. I've got my overall. The only thing I need at this point, if you look at what I have so far, I'm going to make this midpoint here. And it doesn't matter. Either line I think would be fine. And I'm going to make hold control and make the part origin coincident. So there are still some blue entities here. I think, let me try this. Let me move this around. Okay, so it's not fixed. It's fixed to the line, but it's not fixed relative to the line. So I think if I made, let's try, oops, what the heck? Get out of there. That's that Windows tab. I don't like that. Close all. Okay, if I make, let's try and make these three symmetric. I'm going to make this arc, and what about this point? I can't make those symmetric because it's a point. Let's see, what else can I do? Let's trim it and see. I think maybe if I trim it, no, it still has issues. Another quick one might be just to, let's see if I can just smart dimension this line length. And whatever that is, that's just kind of a quick way to do it. I think that's good, actually. This dimension shows this kind of wonky dimension. And I think that's okay, but I'm going to double check. I'm going to click on this dimension, and this value is correct to the drawing. So as long as this value is correct, this is just whatever this tangent point is, where these lines are, so, or where these center marks are coincident with this. This is actually the axis of rotation, and I'm going to use that line actually for the axis of rotation right now. This looks pretty good. I'm not sure how they do it in the book, but the book is accurate to the drawing, so you can just follow those. However they define their drawing in the book is fine as well. So from here, I'm going to say I'm my sketch is fully defined, but let's before I go any further, I'm going to add my name. The title is ball joint arm. I'm going to say yes. Uh-oh, I'm doing the wrong one. I'm doing the T joint. This one is actually the T joint. And then I'm going to do a file save as. And what I had done was on my desktop, I had placed a folder here that says ball joint assembly. And I actually had previously done the T joint. So I'm going to actually replace my T joint. I'm going to highlight it in my folder. This is going to be my file name, Buechler M T joint. And I'm going to go save. It already exists. Yes, I want to replace it. So now this is my new T joint. So from here, escape out of the dimension tool. I'm going to select from a fully defined sketch features, not extrude, but revolve. So this is a revolved part here. And the blue box, the blue prompt is asking me to select the axis of revolution. I'm going to select this line. Oh, come on. Let's try that again. Revolve. The axis of revolution is not a selected contour. It has thin feature. For some reason this was highlighted and it's not allowing me to select this line. You can see it's looking for an area. If I deselect this, can I select the line then? No, I can't. Yeah, now I can. I went back in and prompted that. 360. I don't see a good preview here, honestly. But I'm going to say yes. Maybe there's other issues here. It says there's intersecting entities. And that was why it showed there. If there's an intersecting entity, it will select this by default. Now, this one's pretty easy to get around because I know my intersecting entities would be on, there's not a lot to this, so it'd be this, one of these four corners. So I see the corner here, and maybe this is why it wasn't defined. I'm actually going to delete that dimension, and I'm going to go back in and trim this. Dun, dun, dun. In the sketch, trim. Now if you noticed, I deleted that dimension. I was curious why I needed that dimension because I didn't think I needed it. And now I trim this corner away. I guess I didn't trim it correctly to begin with. Sometimes there's multiple lines in there and you think you're trimming to a line, but you're actually trimming what, you know, a second line or something. So sometimes the trimming is an issue. So now it does show down here fully defined. In my property manager it shows a minus sign as underdefined, but it is fully defined. It just needs to be rebuilt. But I'm not going to do that. I'm going to go ahead and select features again, revolve, and then now the prompt for this line is my center line axis of revolution. The preview looks good. I'm going to say yes and continue on. Now on this one, this one's a little tricky, and this might be some of the harder stuff we do. I'm going to do it a little different than the book, so please pay attention. If I go to this sketch and I go normal to my sketch 1, this is the plane that I sketched this half revolution on, and you can see that outline. I'm now going to select the opposite, which is the top plane, not the front plane. If you zoom out, you can see I sketched sketch 1 on the front plane. On the top plane, I'm going to do our second entity, and I'm going to select sketch, sketch, right from this menu top, and then I'll go normal 2. It doesn't look correct because it doesn't show, let's see here, it doesn't show a second sketch in there. So I did something a little bit weird there. Let me look at this thing again. So I'm going to select sketch. Here it goes. From the flyout menu, I'll select top. Now I'm in sketch 2. You can see sketch 1 is on the front plane, sketch 2 is on the top plane. That's what my normal 2 view is right now. So from here, I'm going to select one side over here. Very different than how the book does it, and I'm kind of curious why I think it's a lot harder in the book version. I'm going to make 2 circles, actually 3 circles. I'm going to put another circle over here. And then 1 line, and the line's going to go like right here. And you could start this line actually coincident with this edge. And I'm going to smart dimension, even though this one's small. I'm going to go off the drawing. There's 2 diameters here that we're going to trim together. So this one is 0.375. This will be the smaller one. That's the radius size, so I'm going to multiply that by 2. And then this larger one is going to be 0.425 radius times 2. That gives me the diameter. And now this looks pretty good. The only thing I'm going to do is this center line right here. I want to make sure this center line is in between these 2, and then it gives me this. I'm not sure what this is it's coincident with this line, which I definitely don't want. So I'm going to delete that sketch relation. I'm going to actually move this up a little bit. Zoom in here. And I'm going to make this arc and this arc, these 2 arcs, the smaller arc, tangent. And then very important that this center line is on the inside of this arc, because I'm going to select again the small arc and the outside arc and make those also tangent. So that's going to, these 2 sketch relations is going to control this diameter. On this particular sketch, the only thing I need to do to define where this is dimension it from the center. And there's a linear dimension as well, but let's look at where this is vertically. You can kind of see it move around a little bit. So to constrain this vertically, I'm going to select arc center, part origin, and I'm going to make those horizontal. I'm going to add a linear dimension as well here, and it's going to be dimensioned from the origin to the arc center. You can just select the arc, and I'm going to go 3.268, and I'm going to divide that number by 2, and it's starting to turn black. It's really getting defined here now. So these 2 arcs, it's tangent to this point. This matches our little concave surface here. So this is looking pretty good. I'm going to drag this over here a little bit. You got to always escape out of the dimension tool. Now, in the property manager, I'm going to select and right click normal 2. I'm going to zoom in. I'm going to select this edge and this line, and you're actually able to select a silhouette edge, and I'm going to add a collinear relationship between these 2. And you can actually see this line is now defined. The length is not defined, but it's constrained collinear to this edge. And then again for this arc, the only dimension I need to add is from arc to, actually it's point to point. I'm dimensioning point to point here. If I drag this out this way, it's kind of a little wonky when you do point to point. I'm going to put the value from the drawing is 0.250. So that looks pretty good. Everything is, oh, it still shows as underdefined, but I think once I trim this, this is going to go away. So let's use the trim function. I'm going to drag my little line here, cut, cut, and you can actually see these two endpoints of this line trimmed to the endpoints of the arc. And that defines, that constrains this line based on the endpoints of these arc here. There is one other issue when you do this trim, is the inside part of this arc. I'm going to drag and trim that away, so now I have a shaded closed contour of which to do a revolve extrusion. I do have to add one more thing before I do that, and that is a center line. So I'm just going to go from my origin, and really you can put this anywhere, but it does, you do want this to be a horizontal line. Now I'm going to rotate my drawing a little bit here, rotate my sketch, and you can see it shows down here fully defined. It looks good. This is what, there's not a whole lot to this, but I think the hardest part is kind of getting this line correct. And there's a few different ways to do this line. I think drawing the circles, dimensioning them, and trimming them is probably the easiest. The book does it a little more, I don't know, it seems a little more complicated in the book. So from here I have this fully defined sketch. And I have a center line. I'm going to Features, Revolve, and it automatically populated my center line. So I didn't have to select this center line as my axis of revolution. But I do need to change, the default value is 360. I'm going to go to 75 degrees. That's on the drawing. And using the default planes, you can see this goes up on one side. So I'm going to actually use, for direction 1, the mid-plane option. That's pretty key. And I'm going to say yes. So this looks pretty good. Dun, dun, dun. If you rotate this and bring this close, with the merge option, if you have the dimensions correct, there's no line in here. And these two different sketch extruded entities merge to actually form one solid piece. So this looks great. So I've got sketch 1 for my revolve. Sketch 2 is my little finger handle here. Again, you can kind of tell how the orientation using the default planes now, this is pretty key, and the origin for the right plane, and we'll show you that at the end here. But to continue on, we're going to use the mirror function, and we're going to mirror from the feature tab, not mirroring a sketch, but we're going to mirror a feature. So I'm going to select mirror from the feature tab. The flyout menu, I'm going to open my flyout menu, and it's asking me here with this blue prompt, what face or plane am I going to mirror off of? And in this case, I'm going to actually use, I'm going to mirror a mirror, but the first mirror actually doesn't even matter. I can do front or the right side. So actually in this case, I'll use the right side default plane. The feature to mirror is going to be not the sketch, but the extrusion revolve 3. And it actually looks pretty good. The preview in yellow looks pretty good. I'm going to say yes. And you can kind of rotate this around and see that that also is blended. Dimensionally, it's correct. Let's mirror now a mirror. So again, in the Feature tab, I'm going to select Mirror. And it already populated Features to Mirror. It's going to mirror Mirror 1. And it's going to populate this second mirror as Mirror 2 here. And it's asking me, with the blue prompt again, what face or plane do I want to mirror off of? Well, I know I did the right plane, so I'm going to use the front plane. And the unique thing about this feature on Mirror 2, the preview looks good. I can kind of rotate this around. This looks good. I'm going to say yes. The unique thing about Mirror 2 is it actually mirrors the original Revolve. So Mirror 1 just mirrored this, but Mirror 2 mirrors both the Revolve and the Mirror 1. So it's kind of a little wonky how it does it, but it works. So that looks great. This is exactly what I'm looking for. Before we go on to the T-joint part, you're going to need to make sure you have the correct fillet. So let's finish that part here before we go on. I'm going to select, there's two different size fillets here. One here, I'm going to do, you want to do or can only do one size at a time. So I'm going to do these four. I think the default size is 100 thousandths. So if you look on your drawing, this value needs to be changed 0.08, and this is only on 4 edges. And you don't want to select any faces in here or loops or features. So this is just edges. That looks good. And then if I zoom in, you can see there's still a square corner here on this fillet, but this looks good. Now, you definitely want to do this smaller fillet last. That's critical on these fillets. And I'm going to change this value before I select. It's going to be 15 thousandths value. And on this, you also want to select edge. Do not select this face because the face will try and do, it has like this inverted fillet in there if you select this face, and it won't even, it doesn't give you a preview because it will not work. So instead of a face, I'm going to deselect the face by selecting it. I'm going to select the edge, and it's going to be, the option is default tangent propagation here. And that means that whatever edge you select, it's going to continue on all the way around any edge that's tangent to the edge you selected. So if you actually just go in and select 1, 2, 3, and you're selecting transparent here, so you got to be a little careful. There's 4 edges here, and there's 4 edges here. 4 edges here. I'm sorry, 8 edges total, right? 1 through 8 here. 4 on each side, 50 thousandths. And that is the last feature on this part of it. But we actually need to do the T-joint part as well. But this looks pretty good. Remember, if you're watching me, and part of this is, doing what's represented in the drawing. There's not a lot of creativity as far as your part, but there's view manipulation, making sure your dimensions are correct, and making sure you're able to find and manipulate the other features within SolidWorks here. This looks a little weird here where the fillets are, but it's correct like this. Okay? So the last piece of this puzzle here is another sketch. And this one, if you've done this base sketch correctly, this one is very easy to locate. I'm going to select the right plane, and I'm going to go down here to my design tree and select normal 2, and then start sketching. And I'm going to start from my origin. I'll bring it all the way out here, make sure this is a horizontal line. I'm going to go with an arc here, and I'm going to use the arc to arc function again. I can zoom in. I'm going to do an arc this way, a line, an arc, a line, an arc, and then a line. I'm going to make sure this is also a vertical line to here, and once I select make this a closed contour, it will become shaded. I think probably maybe the best one to do here, dimension first, would be actually this shoulder. And this is going to be 250 divided by 2. And then maybe let's do the shank here. This is going to be 550 divided by 2. And you can see that this ends up being, there's no sketch relation tangent to this outside diameter, but it is the same size. Okay. There is also a linear dimension from arc to line. On the drawing it shows as 1.75. The diameter here is 0.368 divided by 2. I'm sorry, that's incorrect. 0.368 times 2. No, that doesn't look right either. Oh, it is a radius dimension. I'm thinking it's a diameter. 0.368. How about that? Looks good. Now, there's this value here. Is this where the shoulder is? So I'm going to drag this line back. And with these smaller arcs, maybe I should have dimensioned those first. But I'm just going to put it there, and I'm going to show you a few things that you got to be aware of on this. Each one of these smaller arcs has tangent relation to each line here, except for this one. There's no tangent relation between this arc and this line. So you can actually add that as you sketch. Just pay attention when you're converting and you're using the line arc function in Sketch Tool. Just kind of make sure. I think one of them, I think it's the first one, it does automatically, but the second one it doesn't do automatically, but you can get it in there. Like this one, I had this one put in there, actually this one too, but I didn't get it. I was kind of not paying attention on this one. So make sure, I'm going to select arc and line and make them tangent, and then the other dimension would be the radius, 0.05 off the drawing. I'll make 1, 2, 3 arcs equal in size, and then I think I just need the distance from arc center to the shoulder. Off the drawing is 0.475. So this looks pretty good. There's kind of a lot going on in here, and this can be a little tricky, but just again take your time. It's more view manipulation and making sure you kind of dimension as you go, in a sense. Again, maybe the radius ones are a little easier to dimension. So from here, this looks pretty good. I'm going to select Features, Revolve, and I don't need a center line because it's prompting me the axis revolution. I'm going to use this line. And the preview looks really good. I'm going to say yes. So this is my T-joint. The only thing I'm missing now is features, fillet, make sure this is also included. There's 2 edges here between these 2 diameters, edge 1, edge 2. This is a value on the drawing of, I think it's 100 thousandths. Yes, so this looks good, and go ahead and file save as, making sure this is correct. I'll overwrite, I could have just saved it. And that's our T-joint.